Hello all, myself Mrs. Ketaki Bhoyar from Dr. D.Y. Patil Institute of Engineering Management and Research. I am from Department of Computer Engineering. Today I am going to discuss environmental and sustainability aspects with respect to software engineering under International FDP on Environment and Sustainability organized by D.Y. Patil College of Engineering, Akurdi. These are the details of my two videos. The first video explained about what is software engineering and different aspects of software engineering with respect to environment and sustainability. Second video, it explains about different issues to take care while developing the software so that you will develop a sustainable and environmental friendly software. Then, outcomes of the video. Students will be able to understand various aspects of sustainability in software engineering. They will apply the improvements in software development process in view of environment and sustainability. They'll learn to develop the energy efficient and sustainable software. Let's see some of the ISO standards related to the software engineering. ISO or IEC 25000 2005 is commonly known as the standard that provides the guidelines for software quality requirements and evaluation, which is also known as SQUARE. SQUARE is divided into subparts, such as there are different ISO standards and their specifications. So ISO 2500N, this standard is defined for quality management division. ISO 2501N, it is defined for quality model division. ISO 2502N, it is represented for the quality measurement division. ISO 2503N, it is represented for quality requirements division. ISO 2504N, it is represented for quality evaluation division. All these ISO standards are represented for the software quality requirements and evaluation. Quality Management Division standard is represented for the quality management of the software. Quality Model Division standard is represented for the model of software. Quality measurement is for the measurement of the software. Then quality requirements and evaluation are for identifying the requirements and evaluation criteria while designing the software. Then let's see some of the IEEE standards. IEEE standards are specifically related to software testing. As in my last video, we have already seen about the software development lifecycle to develop the software. Software testing is the second last step of software development. After testing, we deploy the software. So there are some IEEE standards that are defined for testing the software after the complete development. So IEEE 829, this standard is represented for documents used. It is represented for the format of documents used in different stages of software testing. IEEE 1061, it is a methodology for establishing quality requirements, identifying, implementing, analyzing, and validating the process and product of software quality metrics. IEEE 1059 is the standard for represented for software verification and validation plans. Then IEEE 1008 is the specification for the standard of unit testing. IEEE 730, it is the standard for software quality assurance plan. IEEE 1061 is the standard for software quality metrics and methodology. Now we will see carbon emissions. Now carbon emissions while developing the software. Software is usually developed in plan, design, implement, test and deploy phases. To develop a software product, we use laptops, hardwares, design algorithms, we connect multiple servers and clients, we use multiple storage devices, etc. So what are the carbon emissions related to all of this that we will see, and then we will see the carbon footprints of each and everything. Now in this slide we will see the carbon footprint calculations. Uh, Let us calculate carbon footprint for software development. Consider we are going to use hardware or Arduino kit for developing a product. Carbon footprints for the laptop are: laptop generates around 350 kg CO2 equivalent per year. It is considered from a US based study. Then any hardware, we can use any Arduino kit, we can use any Raspberry Pi kit or any other type of kit. Usually production of the kits, they have higher carbon emission rate than using the hardware itself. So hardware has a minimum amount of carbon footprint, we can consider it almost negligible. Then majorly the carbon emission while developing the software, it majorly depends upon the algorithms, the logic you apply. Then what is the time complexity of the algorithms that you are using, which you are developing the software. Time complexity is directly proportional to the CO2 emission. If your time complexity is higher for your software to run, then obviously your laptop will run for that particular time. Response time of your software will be response time of your software will be greater. If response time of your software is greater, then there will be CO2 emission greater, higher CO2 emission, because it will produce higher CO2. Then the server farms. Server farms means where multiple servers are connected for the development of a software, and multiple servers are continuously running. So they have 350 kg of CO2 equivalents per year. Then the storage devices we are using for running an application, storing 100 gigabytes of data in the cloud per year would result in a carbon footprint of about zero point 0.2 tons of CO2. So this much carbon emission is expected for development of a software. If we are reducing the usage of all these hardwares or softwares, or if we are reducing the time complexity of the algorithms that we are using to develop a software, we will definitely develop an environment friendly software. Even environmental conditions responsible for developing software applications also matters. In IT industries, usage of air conditions are there. In many of the institutes also, higher usage of air conditions are there to maintain their servers, to maintain their multiple laptops and computers and desktops and their workstations working. So if not necessary, we should not use the air conditioners. Wherever necessary, there only air conditioners should be used so that it should not pollute the environment. Then we will see one case study. In this carbon emissions are considered for the company of Amazon Web Services. This diagram is taken from a source of 451 research, which AWS, Amazon Web Services, published online. So this is the carbon efficiency of AWS infrastructure compared to the survey of US enterprises. Here, 61% of carbon reduction is attributable to more efficient servers and higher server utilization. 11% of carbon reduction is attributable to more efficient data center facilities. 17% of carbon reduction is attributable to reduced electricity consumption and renewable energy usage. Then regarding sustainability of a software completely depends upon the cost of software. It must be determined where the financial, environmental and social resources of the company, it create more return within the company. We cannot exactly mention a month or a year or a particular digit for a software to be sustainable, because it completely depends upon what components you are using to build that particular software. So nowadays also we are getting multiple updates for the software. So we cannot say that the software is sustainable for a month or it is sustainable for a year. A software is not sustainable. The components that are used to develop a software, they can be sustainably used. Like laptops, we should also be able to handle the e-waste, as while developing the software, handling of the e-waste is the major problem. Conclusion: build a sustainable software in eco-friendly environment which will provide maximum benefits to society and hence people. Thank you.